Hey peeps, welcome back. It's Aldo from the Zero to Mastery Academy, and today we're diving into Java variables. Maaike Van Putten will be leading the charge, an exceptional instructor from the Zero to Mastery Academy. This tutorial is just a small glimpse into what's included in Maaike's extensive Java programming bootcamp course. So if you really want to master Java, I strongly recommend you check that out, linked in the top right hand corner and in the description down below. That's enough talking from me. Let me hand it over to Maaike. Enjoy!
It's time for a new topic that we actually have touched upon already, variables. Without variables, our code would do the exact same thing every time we would be running it, over and over again. Even though that could still be somewhat useful, for example when we're automating manual tasks, it's typically not what we want. Luckily, we can work with variables, so we don't need to get the same result when we run the same program twice. They make our program vary, so to say. This might not be the most helpful explanation, but let's look at variables in mathematics first. Now, if mathematics is not your thing, don't be scared. You can get quite far without probably 95% of high school math. But you will definitely have to be able to understand things like this. 2x equals time. What is the value of x here? Right, it's 5, because we divide both sides by 2 to get the answer. And 10 divided by 2 is 5. So, what would be the outcome if we would have set the variable to 7? If x equals 7, then what does 2x equal? It would have been 14, because 2 times 7 equals 14. Let's look at another example. Say we have a variable containing a word, and this variable is called name, and we use it as a display message like this, hi, plus name. When name contains Scott, the message will be hi Scott. When the name contains Fatih, the output message will be hi Fatih. So, what will be the output when we run this program? Hi plus name. We don't know exactly. It depends on the value of the variables. Alright, so now we know that variables are building blocks that make our code dynamic. Let's have a look at how this is done in Java. Java variables are very much like variables as explained in the previous video. We use it as some sort of container, passing it around. And what is in it, we'll find out during runtime. Well, partially. We can define and initialize a variable. We need 3 different parts. Type, for example, a number or a piece of text. A name, whatever you want to call the variable, this starts with lowercase. And a value, what the content of the value is, so what the variable represents. In case of a number, the value could be 5. This is what a number could look like. Int x equals 5. Int is the type, x is the name, and 5 is the value. And here's another example. String hobby equals coding. String is the type. This is the type for text values. Hobby is the name of the variable. And coding is the value of the variable. Java forces us to make the type of the variable known during compile time already. Forcing to know the type during compilation means that a lot of surprises, and in this case the surprises are errors, called exceptions, will not occur when running the program, but prior to running the program. So instead of having our program breaking down during runtime, it breaks down during compile time, prior to running the program. We have 2 types of variable types. Sorry if that sounds confusing, but hear me out. We have primitive types and reference types. The reference types are for objects, and the primitive types are for storing values directly. There are a lot of built-in reference types that we will deal with. These are built-in classes, and we have an infinite total amount since you can create your own types using classes. There are 8 primitive types. Let's explore them in the next video. Primitives are the simplest types of variables in Java. A primitive is just a value. There are 8 types of primitives. We have byte, short, int, long, float, double, char, and boolean. The first 4 of them are used for storing integer numbers. They can each hold a number of a certain range. For example, byte can hold a number of negative 128 to positive 127. Short has an even bigger range, int has yet an even bigger range, and so does long, an even bigger range. You can see some examples of each of these primitives on the slide. For example, byte can hold the value 34, but so can short, int, and long. But byte cannot hold the value of 23,000, but short can, so can integer, and so can long, etc. The bigger the number, the less of the primitives it fits into. Let's have a look at how to create these primitives in IntelliJ. Alright, let's start by creating a byte. And we're going to call it b, and I'm going to store the value of 34 in there. This is how to do it. You specify the type, byte, you give it a name, in this case b, and I assign a value to it, in this case 34. Let's do it for the others as well. Here's a special case. If I'm going to create a long that doesn't fit in an integer, I have to tell Java I want to create a long by putting a uppercase L at the back. To be honest, a lowercase l would work as well, but if I use the lowercase l, it looks a little bit too much like a 1, especially if you have a different font. So it's always the best practice to do this with the uppercase L. This way, we tell Java that number on the screen, which is going to consider an integer by default, is not an integer, it's a long. And this is why it doesn't work without the L. Right now it says, nope, this does not fit into an integer number too large. But then we put the L at the back, and then Java is like, oh, it's a long, and then it's all fine, and we can store it in the long value. So just saying that the value is going to be of type long is not enough for Java to realize that the right-hand side of the equation is actually a long as well. You have to specify this manually by putting the L in the back. Float and double are meant for floating point numbers. Doubles have a bigger range and higher precision than floats have. Here's an example of each of these numbers on the slide. Float has a value 3.2, and this can be stored in both a double and a float. The value of the double on the slide cannot be stored in both a double and a float. It's too precise to be stored in a float. Let's see how this is done in IntelliJ. So here's how to create the float. And as you can see, we get red squigglies. And this is because, similar to line 8 where we created a long, we need to specify that it's a float. And we do this by putting the letter F after the number. This way Java knows we just created the float. And this is how to create a double. So if I'm going to be creating a floating point number, it's going to assume it's a double by default. So I can store 3.2 in a double like this, but I cannot store it in a float like this. And this is because the default assumption of Java when it sees a floating point is double. More details on this later. So I can store a number this precise in a double. Then we have char. Char is holding a Unicode character. It can also hold a numeric value ranging from 0 to somewhere in the 65 thousands. but it will translate that to the corresponding Unicode character. It can, for example, hold an A. Here's how we can create a char in Java. So we give it the type char, and then we just store some character between single quotes in there, and that's one way to create a char. We can also put a number in there, and in that case it needs to be smaller than 65,535, but bigger than 0. I cannot store a negative number in a char. The last primitive we need to talk about is the Boolean. Boolean can only hold true and false. This is a great data type for storing yes/no values. If the answer would be yes, we would store true inside the Boolean value. And here's how to create a Boolean in IntelliJ. We give it a type Boolean, we give the name B1, and I did not call this one B because we already have a B on line 5, and we cannot have two variables with the same name in the same scope. And I gave it the value true. Please mind there's no quotes around true. If you try to do that, it will not work. Let's explore the sizes of these different primitives in the next video. All of these primitives have a size, and depending on their size, they can store certain values. On the slide, you can see a table of the different sizes. Let's zoom in on how this works. As you can see at the very bottom, the Boolean holds a 1-bit value. Every bit can hold a 0 or a 1. In case of a 1-bit, that means that there are two options, 0 or 1. Since a Boolean can hold a 1-bit value, it has two options only, 1 and 0, which makes sense because it only has the options true and false. Even though the Boolean data type represents 1 bit of information, its size isn't precisely defined. That's why the very bottom row is a bit vague. Here you can see 1 bit, and 1 bit is depicted as a little square. In this case, a bit can hold two values, 0 or 1. So if we have 1 bit, the total number of options is 2. Alright, so this is how it would sort of work for a Boolean. Let's keep that in mind. If we look at byte, byte is an 8-bit signed value. What does this mean? Well, 8-bit means that we have 8 options for 0 or 1. This would give us a total of 2 to the power of 8 options. As you can see on the slide, every cell holds 2 options, hence we go to 2 to the power of 8, since we have 8 cells, 8 bits. This equals 256. The highest number we can get to with a Boolean though is 127. This is because it's a signed number. We can also have negative numbers. All the negative numbers, 0 and the 127 positive options, makes 256 options in total. Alright, to wrap up on the primitives. We have had a look at the primitive values. We've seen primitives for whole numbers, integers, byte, short, int, and long. And we've seen primitives for floating points, float, and double. We've also seen primitives for characters, namely char, and for booleans, the true and false values, namely boolean.
And there you have it, folks. That's your introduction to Java variables, expertly led by Maaike. If you enjoyed this lesson and want to learn more, then I strongly recommend you check out Maaike's complete Java programming bootcamp course, linked in the top right-hand corner and in the description down below. Also, don't forget to like, subscribe, and hit that notification bell so you never miss out on future tutorials from Maaike and other expert Zero to Mastery instructors. Keep coding, keep learning, and I'll see you in the next one.